Hello everyone, and welcome to lesson 8.7, which is on factoring quadratics where a is greater than 1. Now, in this section, we are going to be looking at quadratics where our lead coefficient is 2, 3, 4, 5, something larger than 1. Whenever we factor these problems, we know that the first step in any kind of factoring is to check for the greatest common factor. We've done that in all of our previous steps. We did that back in 8.6. We were always like, check for a greatest common factor. But whenever we have these problems, checking for the greatest common factor is going to lead us down two roads. The first road is, hey, I'm able to take a greatest common factor and divide a greatest common factor out, and that's going to leave me with an a equals 1 type problem, just like we saw in 8.6. So if that happens, once we take the greatest common factor, all we have to do is follow the steps in 8.6 to solve those problems. So if you want to see an example of how to factor that way, I would say go check out that video. That will help you guys out. The second road that we travel down is after we take a greatest common factor, we still have our lead term greater than 1. Or maybe we can't take a greatest common factor, so we just have this quadratic that has a number out in front, a 2, a 3, a 4, something out in front that we got to deal with. So if that happens, we're going to use something called the AC method. Now, the AC method has 5 steps, and the AC method says, step 1, we're going to multiply A times C. Well, what does that mean? So if I have this sample problem to the left here, 4x squared plus x minus 5. When I say multiply A times C, right, remember in our quadratic we have ax squared plus bx plus c. So we know what A is, we know what C is. Those are positions, right? Those are telling us exactly like specific locations in the quadratic. We're going to take our first term, which is 4, and we're going to multiply that by our 5. So when I do that, I will rewrite my problem as x squared plus x, and then 4 times negative 5 is negative 20. All right, so there's our first step. And the only reason that we did that little manipulation to the problem was to get it into a form how we've seen before, right? We've done this in 8.6. Well, in step number 2, we got to factor like we did in 8.6. Well, what does that mean? Well, we got to take our 20 and we got to write our factors of 20 out, right? 1 and 20, 2 and 10, 4 and 5. Well, how can I get a positive 1? Because really there's a 1 in the middle there. How do I get a positive 1 out of those? Well, I can't out of the first 2 terms, but I can out of the third. The way that I get a 1 is by taking positive 5 and subtracting 1. So that gives me my parentheses x plus 5 and x minus 1. So the whole purpose of doing step 1 is to just get it to where I can factor it out into 2 parentheses. Step number 3 is all about fixing that step that we did. You know, whatever we do, we have to undo. So all I'm going to do is divide just the number, and when I say just the number, I really mean just that number, by A. And A, again, was our lead term, which was 4. We divide that out. Oh, crap. I just realized I wrote a 1 here. Knew something looked different. All right, so now I'm dividing each of my numbers by A. On the left-hand side, 5 over 4 doesn't reduce or anything, so that just gives me x plus 5/4. On the right-hand side, 4 divided by 4 does simplify, and that just becomes 1. All right, so now I have now I have my answers here, right? X plus 5 fourth and X minus 1. We've done that. We've reduced. We've simplified as we've needed. And now the last step is to slide a denominator. And the reason we have to slide the denominator is because we're not allowed to have fractions anytime we factor. So all we're going to do at the very end here is we're just going to take that 4 and we're going to slide it right in front of that x inside the parenthesis. So my first parenthesis becomes 4x plus 5. And my second parenthesis stays the same. And now I've used AC method. Let's go back over that one more time just so we can see it. Step number 1, we multiplied A times C. Step number 2, we factored the problem as normal, or as we learned how in 8.6. Step number 3, we divided both sides by A. Step number 4, we looked at reducing, but we can't reduce 5 over 4. That's in lowest terms. We were able to simplify 4 divided by 4 into 1. So we did that in step 4. And then in step 5, we slid the denominator to get our final answer. So I understand that that's a lot of steps. And I'm going to be honest that it does take practice to get there. A lot of people, honestly, if they miss a step, they're going to miss this step right here, step 3. They're really good at multiplying and factoring, but then a lot of people just stop. We got to remember, since we multiplied to factor, after we factored, we got to divide to get to our final answer. But other than that, that's the process. So let's look at 2 examples here. We have one example where we do have a greatest common factor. We have another example where there is no greatest common factor, and we'll talk about how to handle those. So our first example is to check the problem for a greatest common factor, right? Is there one? We know there is. So when we go to find our greatest common factor, the first thing that we're going to look at are our coefficients. What's the greatest common factor between 2, 8, and 8? That answer is 2. Well, remember, once we divide out a 2, that just leaves me with 4 and 4. And then now we have x to the third, x squared, and x. The most x's I can take out of all 3 is just 1. So that just leaves me with x squared and x, and that one goes away. So what that leaves me with as an inside piece is x squared plus 4x plus 4. All right, so now that we are here, my attention is only, and when I say only, I mean only, on this highlighted piece in the middle. Okay. All I have to do is factor that inside piece. The greatest common factor that's on the outside, I'm not worried with. So I'm just worried about factoring that piece. When I factor it, I got to find what numbers multiply to give me 4. That's 1 and 4 and 2 and 2. Can't get 4 from the first one. I can from this second one by taking positive 2 and adding 2 to it. So that gives me 2 parentheses of x plus 2, x plus 2. And then my 2x that's on the outside is there. And I have my final answer. So anytime we have a problem with a greatest common factor, I've got to first take the common factor out, then my attention shifts and focuses on what's inside the parenthesis, and I factored that just like I did in 8.6. All right, number 2 is a problem where we have no greatest common factor. So we know if we have no greatest common factor, we have to use AC method. Now, AC method starts with multiplying A times C. So we take this first number 4 and we multiply it times our 3. When I rewrite, I start with just x squared plus 7x, and then 4 times 3 is 12. So now that I have that, the whole purpose again of doing step 1 is just to get the problem like it looked in 8.6 so we could factor it. Well, now we got a factor, so I need to find my factors of 12. I end up with 1 and 12. I end up with 3 and 4. I end up with 2 and 6. Skipped over that one. Well, which factor pair can get me 7? And positive 7 at that. That's going to be positive 3 plus 4. So now I have my parentheses, x plus 3, x plus 4. And that takes me through step number 2. Step number 3, I have to divide both numbers in the parentheses by a. So let's do that. Divide by a, which is 4. So 3 divided by 4 and 4 divided by 4. So I've done that. To reduce, I can't reduce 3 over 4. It's already in lowest terms. 4 over 4, I can reduce that or simplify that to 1. My last step, I have to take this denominator here because I can't have them in fractions, and I have to slide it right in front of that x inside the parentheses. So that gives me 4x plus 3 and x plus 1. And that is how we handle factoring whenever a is greater than 1. I understand that these have a little bit more complication to it, so if you guys have questions, if you have problems, if you need clarification, especially on AC method and making sure you're getting all the steps down, please reach out to me and let me know.